I'm curious about immune system and immunity. This has obviously been something that people have been thinking about a lot more in the last few years with everything that's happened globally. But I think immunity and the immune system is actually something I've been fascinated by, because I don't think actually people understand what it is. I don't think I understand fully what the immune system is. So if we can start with that first, what is the immune system? What is it intended to do for us? How can we own it? And also, is it possible to have full immunity over viruses and diseases?
Oh boy, there's a lot of stuff wrapped up in that. So let's unpack that. Let me start with just a simple concept that I think describes why I'm so interested in the immune system and why I think everyone else should be as well. So it turns out that every minute that we're alive and not sick, that we're producing about 1 million new immune cells, which means if you do the math, the total number of immune cells that are in our body, it means that about every 3 months we've completely reformed our immune system with new cells. Now the question is, those cells that we're reforming every 3 months, are they as good, better, or worse than the ones from which they were derived? And what has turned out, as people have studied this, and I'm now speaking about immunologists who are investigating this, is that over the course of living, for the average person, the cells that replace these old cells are worse off than the ones that they are replacing. They're worse off, meaning they have undergone aging. This is called immunosenescence. And it turns out that that process of immune aging is why we see, for instance, SARS-CoV-2, COVID-19 appearing more seriously in older age people, because their immune system is kind of starting to be worn out. They've undergone what's called immunosenescence. Now, it turns out that that is a biological property that is related a lot to how your immune system is being treated over the course of your living. It's not a locked in, you will have this bad immune system when you're 65, or you'll have this great immune system when you're 25.
So you can control the outcome of your immune system.
That is the lesson of this discussion.
Wow.
Yes.
Okay.
And we call that kind of the biological age of your immune system, as differentiated from your number of birthdays, which is your...
Not the chronological.
Right, exactly.
Okay.
So
you can track the biological age of your immune system?
yes, and we've been doing that. There are ways now scientifically to do that, fairly conveniently, by the way, if you are in the laboratory, which we are. And you do that by actually looking at how the genes in your immune cells are undergoing injury or change. And the way we do it is, rather than looking at injury to the DNA, we look at the change on what's called the epigenome, epi meaning above the genome. And the actual measurement we use is the number of methyl groups that are stuck onto the genes of the immune system. Now, some of those, that's part of the epigenetic process. Some of those processes are related to the adaptation of the immune system to be better off than it was before, but others of those can lead to the immune system aging. And we can measure where those methyl groups are put and how they track with performance of the immune system. So is it possible then to take a person, say 30, take their blood, spin their blood down, take the buffy coat of the blood, which is spun down, which is where the immune cells reside.
Is that the white part then?
Yeah, that's the white part.
Not the red.
Precisely.
Right.
Yep. The red cells are in the red, that's the erythrocytes, but the white part is the buffy immune cells. And you can then subject those to this kind of study I'm talking about, this epigenetic sequencing using gene chip technology. When you do that, you can find out that people that are 30 may have immune system function at the epigenetic level of a 60-year-old. Or you may find a 60-year-old that has the immune system of a 30-year-old.
Interesting. What are the main factors that determine a weaker immune system in a 30-year-old versus a strong one in a 60-year-old? What are they doing differently that causes them to be weak or strong?
Okay, so that is really where the Rosetta Stone lies, is the answer to that question. So let me give a best approximation, because I don't believe anyone fully has answered that question, but we have some pretty good, at least first-level understanding. So if a person is exposed to a lot of stress, if they don't sleep, if they're a smoker, if they consume excess alcohol, if they don't exercise, they eat extremely ultra-processed foods, if they're exposed to xenobiotic toxic chemicals, every one of those things that I just mentioned is an agent that modifies how the immune system is marked epigenetically and can contribute to immunosenescence, immune aging. So if you wrap those things together and then lay them on top of a person's genes, because you might say, but But Jeff, I know a person that has all those things and they're perfectly healthy and they're 90 years of age and they've never been sick. Well, yes, there are those exceptions, certainly, related to their genetic luck of the draw. I call it their book of life, 26 chapters, 23 chapters that's encoded in their chromosomes. Those things might have been the luck of the draw that helped them to resist. But for most individuals, what we will find is those characteristics, as you load them up on the immune cells, you will see more and more of the injuries that pertain to aging of the immune system.
Wow. Yeah, there's a lot of damage when you start to stack those challenges on the immune system over time. Maybe in your early 20s, you can handle it, but then as you age each decade, it's probably harder and harder to recover faster from sickness or illness or injury, right?
I think, Lewis, you said it. This is what I call resilience. And, resilience is a characteristic that I think we haven't given enough credence for. We did a survey of 15,000 individuals on our website asking, what's your definition of health? And out of those 15,000 individuals, only a few of them said absence of some disease. I don't want to get cancer. I don't want to get Alzheimer's. I don't want to get heart disease.
What do most people say?
They said, I want to be able to run a marathon. I want to learn new tasks. I want to be successful at work. I want to have the energy to play with my kids. I want to be able to climb mountains. All these variety of human functions that relate to the expression of joy, diversity, performance. It wasn't about the absence of disease. It was the presence of function, the presence of performance. So the immune system gives us that flexibility. It gives us the resilience to be able to jump on a plane and go to Kathmandu or to go to Kilimanjaro and hike the mountain. And if you have an immune system that's not properly configured, you end up with more probable acute mountain sickness and other things that happen.
Right. Now, you're known as the father of functional medicine. Why is the immune system and immunity something that you've dedicated most of your work to understanding?
Yeah, thank you. So that is a part of my 40-year learning. So right now, if I was to list the major concerns, health concerns that people have throughout the course of living, it would be things like dementia, maybe Alzheimer's. It would be cardiovascular disorders, which still constitute the number one cause of premature death. It would be autoimmune disorders. There are 88 different diagnoses of different types of autoimmune disease. It would be diabetes, particularly type 2 diabetes. It would be obesity. I could go down the list, but that's a pretty good start. Every one of those conditions that I just mentioned is an immune-related dysfunction.
They're connected to the immune system.
Every one is an imbalanced immune system.
Interesting. Really? So when you look at these diseases, you'll see that there was a break or a weakening in the immune system.
That's exactly right.
And that's part of the reason why these diseases were formed or caused, because the immune system wasn't able to fight against whatever forces were coming at them.
So let's use an example that probably most people would not be aware of. Let's think of the brain. So people would say, well, these cognitive dysfunctions, early stage dementia, memory loss, foggy brain, that can't be an immune problem, Jeff. The brain is up there all by itself. It's got the blood-brain barrier. It's separated from the rest of the body. But it turns out the brain has its own immune system. This is called the microglia. These are cells that are actually in the brain. They were called microglia. Glia is from the Greek meaning glue-like, because they were just thought to be glue-like cells that glued the neurons of the brain together. But over the last particularly 30 years, it's been found, no, these are actually the brain's immune system. And they crosstalk with the immune cells that are floating in our blood, which crosstalk with the immune cells in our liver, which crosstalk to the immune system that's in our gut. Do you realize that 60% of our immune system is clustered around our intestinal tract?
Wow.
So all of those are crosstalking. This explains why people with gluten enteropathy that can't stand gluten, because of their immune problems in their gut, it speaks to their brain and they have higher levels of dementia.
Interesting. So wait, how many immune systems does the body have? Because I'm hearing a brain immune system. There's a gut immune system.
I'm glad you brought that up. This is another probably aha for some people. The immune system resides in every organ of the body. We have the myokines in the muscles. That's why you get sore chronic muscles with either overtraining or undertraining. You're actually altering the immune system that's producing these inflammatory mediators that are in your muscles. The same thing holds true for the liver. This rising tide of non-alcoholic fatty liver disorder that we're now seeing even in kids, that's a consequence of immune system in your liver gone awry.
So why is the liver being affected if someone's not doing alcohol? Is that from processed foods, sugar, gluten, or other things? Or how is the liver being affected to someone in their youth?
Okay, so you're asking superb questions. It is really fantastic. So here is the operative model of how that occurs. So we would all agree that we've changed our diets considerably over the last 100 years.
Yes.
Maybe even want to say over the last 50 years.
The SAD diet, the standard American diet.
Exactly right. So we have a lot of these ultra-processed foods that are very high in blood sugar stimulating effects, and they also bring a lot of other agents into the diet that activate the immune system to say, I don't really think these are friendly to us. They're unfriendly. And when the immune system recognizes a foreigner or a non-friend, it has got the principal responsibility of defending us from that, not just viruses or bacteria. So where does this start? Well, most people eat their food orally, and that means it starts in the mouth. You consume, digest into the gut, and now you feed the remnants of that food to your gut microbiota, the so-called microbiome. The microbiome is composed of literally thousands of different critters, each with a different personality, that picks up the information from your food that you've eaten and partially digested, and it then sends signals from its metabolism that are picked up by the intestinal wall where the immune system resides. It's called the gut-associated lymphoid tissue, the GALT, G-A-L-T. So that immune system that's sitting there in the intestinal tracts, picking up the information from your microbiome, that picks up the information from your diet, which is an alarm message because you're eating things that the body doesn't think it should be consuming. And now what does it do? It takes that message into your blood. And where's the first place that that blood goes when it comes out of your intestinal tract? It's the portal blood system that goes right to your liver. So your liver is the drainage organ that takes that information and says, whoa, we're getting a lot of bad pushback here from this diet. We're going to tell our immune cells in our liver that are called the Kupffer cells that they should be aggravated. They then send out a message in the blood that travels to the rest of the body, including to your fat mass. And so now you go from friendly fat to angry fat. And angry fat is where you have a concern about obesity and associated with disease. By the way, there is no data that says that being fat will cause a disease. There is strong data saying that those people that have angry fat have fat that's been activated through their immune system imbalance into a state of alarm. They're the one, and of course that is because of the diets we're eating. That's the majority of people with increased body mass.
Right. Fat in itself is not a bad thing, but an overwhelmingly unhealthy amount of fat is
of the wrong archetype.
That's
right.
Will potentially be a cause of, type 2 diabetes and other things.
So let me say something to that. So for decades, I've run clinical centers, thousands of patients, had many, many research projects we've published over the years. One of my learnings is when a person comes in and they're very worried about their weight, and they have elevated blood pressure, and they have elevated cholesterol, and they have elevated blood sugar, and so they're worried about all sorts of diseases. And they say, well, doc, I'm grossly overweight. I know that from the tables, and I've tried to lose weight, but I've been unsuccessful. And if I have to lose 50 pounds, I just am not going to be successful. Well, the data says that you don't need to lose 50 pounds. What you need to do is to calm down the immune system that's sitting in that fat that's making it angry. That may be as little as 5 pounds of weight loss if it's the right type.
Interesting. So getting rid of that bad fat, the angry fat, the unhealthy fat.
That's right. Exactly.
Not trying to lose 50 pounds, which is this daunting task. Interesting. Okay, so when did the immune system become something that you wanted to really obsess over with your practice and study and research and just diving into? Was it early in your practice, or was it?
Well, when we started the Institute for Functional Medicine, which I'm even saying this, I find hard to believe, was 1991. So we're in our 32nd year of that now being codified. We've had several hundred thousand people go through its programs over those years, health practitioners. I was focusing on how these different organs communicate with one another. I was interested in how do we get a disorder, not how we treat it once we have it. I was worried about root cause. I was worried about what's called upstream. And just then, if you recall, that's before the turn of the century, just then were the new genomic techniques and tools becoming available, where we started to decipher the human genome. As we got into then the 21st century and those tools became available, it started to make a lot of what we had been speculating on in the early days of functional medicine look much more well proven, because now we can actually mechanistically look at how the liver talks to the immune system, how the immune system talks to the brain, And we had tools to actually start examining this from a mechanistic level. Now, let me just finish the story by saying once we had those tools and we were able to start putting the puzzle together into a logical framework, then it allowed us to really go back and say, what are the systems in the body that are the most affected upstream that give rise to this downstream 15,000 diagnoses? And I was very, very fortunate because I've traveled over 6 million miles, believe it or not. I know it's crazy who would do that in their life. So that's a whole nother story. But because of that travel, the benefit it gave me is meeting all sorts of extraordinary, innovative individuals across different disciplines all over the world. And so I started to assemble my list of the people that were really creating this new model. And my wife, Susan, was very insightful one night when I was waxing on, and she said, Jeff, you've met all these people all over the world. You always speak so highly about them. Why don't we host a meeting? You bring these thought leaders in. It's just a whiteboard to talk about what would the healthcare system look like if it was to be idealized. Take away licensure, take away reimbursement. Just talk about the structure of what it would be based on all these people you're talking about. So she hosted, or I guess we hosted, a meeting in Vancouver Island, British Columbia, in Victoria. We brought in about 60 of these thought leaders from different places around the world, different disciplines. And it was really, really an extraordinarily vital 3-day discussion. Everyone said, hey, this was so much fun. Let's do it again. We did it the next year. The second year was when I came up with this concept of calling it functional medicine. And when I went back to talk to the group on that, the last Sunday of the 3 days, they said, well, we're not sure that that's a good word because in medicine today, and back then, function really referred to two things, either geriatric medicine, dysfunction, physical disability, or psychosomatic medicine. It's all in your mind. It's a functional disorder. And that might be really kind of marginalizing what you're saying. But I said, no, I'm reading the literature all the time. And when I'm starting to see articles on functional neurology, functional endocrinology, functional cardiology, they're reframing this as an upstream way of looking using these new tools that will later be downstream pathology disease. So let's capture that. Let's get to where the puck is going. Let's capture that as a term, but with some pushback or reticency, the group said, okay, let's give it a whirl. So that then led us into recognizing that there were, in group discussions, a variety of central processes in the body that were the upstream processes that if they were imbalanced, it gave rise to these downstream collection of diagnoses. And those included such things as the immune system was obviously one of them. Another was digestive physiology. Another was cell communication. Another was detoxification. Another was intracellular cellular replication and the integrity of how cells replicate themselves into daughter cells without losing their function. So we had these 6 basic functional characteristics that we could measure each one of those physiologically. And so then we started to say, okay, can we prioritize those in terms of how they would go into a clinical management program? Because ultimately, we're kind of in this blue sky ethereal area. We need to translate this for clinicians, how they could deliver this in practice. So we developed a program that was our first kind of clinical tool that I'm very proud of. If someone was to say, Jeff, what is the thing is you're most proud of? I think it would be the development of that first program, which we called the 4R program. Those R's stood for remove, replace, reinoculate, and repair. We've taught hundreds of thousands of practitioners that program, by the way. Now, what does that mean? It was our gastrointestinal restoration program. We started talking actually about prebiotics, probiotics, endotoxemia in 1985. That was my first seminar for doctors on that topic. And traditional medicine at that point was really calling us way out there. When we finally then codified this program in the early 1990s, the 4R program, it was a way of doctors actually delivering a program to their patients that was easily applied, that people could understand, that would restore proper gastrointestinal, immune, and digestive function. So the first R was remove. That was take away bad stuff. That could be exposure to toxins. That could be exposure to bacteria, tainted food. That could be food allergens, things that you know were alarming your body. That was the first R to remove. The next was replace. And what we found, and it's actually very well known in medicine, is that a great percentage of individuals suffer from digestive insufficiency. So, in fact, the cells of our stomach that secrete hydrochloric acid to start a digestive process called the parietal cells, something like 50% of people over the age of 50 have defective or dysfunctional parietal cells, which means that they're not able to digest a steak dinner as well. And when you talk to people about, oh, gee, I used to be able to eat this heavy meal and it was still fine. Now I get digestional problems after just a few bites. Well, that's part of the digestive physiology. So we can replace those digestive enzymes as support. That's the second R.
How do you replace them?
Well, pancreatic enzymes like pancreatin, or hydrochloric acid like betaine hydrochloric.
So taking different enzymes.
That's right, exactly. So that's the second R. The third R then is the reinoculate R. Now, what does that refer to? That is going back and repairing what is now called the microbiome. We didn't know that term when we first started, but now that is what we're talking about. And so that has to do with pre and probiotics, reassembling the proper gastrointestinal physiology with pre and probiotics. That's the third R. Are there nutrients that will then restore the damage of the very sensitive one cell thick liner of the gastrointestinal mucosa that separates us from all that toxic junk in our intestinal tract? Because often that becomes damaged, and that's called dysbiosis.